In a town fiesta, singing competition with 12 contestants, in how many ways can the organizer arrange the first three singers? Because the order matters in how the three singers are arranged, this is going to be a permutation, which is P12(3). That's 12 factorial over 12 minus 3 factorial, which is 12 factorial over 9 factorial. And this is just 12 times 11 times 10, which is 1,320. What is P85? This is 8 factorial over 8 minus 5 factorial, which is 8 factorial over 3 factorial. This is 8 times 7 times 6 times 5 times 4. So one way to do this is probably multiply from right to left. 4 times 5 is 20, times 6 is 120, times 7 is 840, times 8 is 6,720. In a school club, there are 5 possible choices for the president, a secretary, a treasurer, and an auditor. Assuming that each of them is qualified for any of these positions, in how many ways can the 4 officers be selected? So this one, not only are you looking at selecting them, but they all have different positions. So the way in which you select them does matter, because one of them could be one of the 4 possible positions. So one could be a president or a secretary, for example. So this will be a permutation. There's 5 possible choices and 4 officers selected. So this will be 5 factorial over 5 minus 4 factorial, which is just 5 factorial over 1 factorial, and this is just 120. How many ways can 8 campers be arranged around a campfire? So think about a campfire that's a circle. You fix one person here, and you need to rearrange 7 people around this one person. So this is going to be 7 factorial, and you always just take whatever number of people there are and subtract it by 1 if it's in a circle. If it's in a line, you just take that number and put it factorial. So if it was a straight line, this would have been 8 factorial. But since it's a circle, it's 7 factorial. How many ways can 11 players form a football huddle? This one is the same idea. This one's going to be in a circle. So you take 11 minus 1, and this will be factorial. Multiply this out and get 3,628,800. A woman has 5 blouses, 3 skirts, and 4 pairs of shoes. How many different outfits consisting of a blouse, a skirt, and a pair of shoes can she wear? This one you just multiply 5, 3, and 4 to get 60. Simplify 12 factorial over 3 factorial times 2 factorial times 4 factorial times 2 factorial. I'm going to cancel out the 4 factorial, so I have to go from 12 all the way to 5. And then that leaves me with 3 factorial, which is 6, times 2 factorial times 2 factorial. 2 factorial is 2. 2 times 2 is 4. Now I can cancel some things out. 6 and 12, that's going to give me 2. And then 4, I can cancel out this 1. And then cancel out another factor of 2, which will be 3 here. So ultimately, I just need to multiply 11 times 10 times 9 times 8 times 7 times 3 and times 5 to get 831,600. How many distinguishable 4 beads can be arranged on a circular bracelet? Because it's a circle, you just take the number, subtract it by 1. So this will be 3 factorial, which is 6. In how many ways can 25 people be seated in a round table if there are 15 chairs? So think of this as a 2-step problem. One step is selecting the 15 people. So from 25, you're going to choose 15. And then from those 15, you have to arrange them into a circle. So because it's a circle, you just take 15 minus 1 and then factorial. This number is way too large, so I'm just going to leave it as it is. Which of the following example holds true about permutation? So this first number, you have a smaller number outside and a bigger number inside. That one you cannot do. For the second one, you have n here is negative, and you can't do that. 0 factorial is not equal to 0. It's equal to 1. Now d, n is bigger than k, so this one works. So the answer is D. Provided an adequate supply of flags in each of 7 colors, how many ways are there to arrange a 5-flag set? So notice here that the word adequate means that there could be reused or replaced. So for each of these 5-flag set, let's say if we have 5 flags, you can select 7 in each one of them because there is an adequate supply of them. If there was an adequate supply, you would just choose 7 for the first one, 6 for the second, 5 for the third, 4 for the fourth, and 3 for the fifth. But because it's adequate, there's going to be 7 for each one. That's 7 to the 5th, which is 16,807. If P9, R is 3024, what is R? So this is 9 factorial over 9 minus R factorial, and it's going to equal 3024. So I'm just going to divide. Basically, I'm going to flip sides. 3024 is going to replace a 9 minus R factorial, and vice versa. Okay. So now what we have to do is calculate 9 factorial. That's 362,880. Divide that by 3024, we get 120. So 9 minus R factorial is 120, which is equal to 5 factorial. That means that 9 minus R has to be 5, so R has to be 4. Using the digits 2, 3, 6, 8, and 9, how many 3-digit whole numbers can be formed if repetitions are not permitted? So we can select 2, 3, 6, 8, and 9, which is 5 digits. So there could be 5 digits for the first one. Because we cannot pick the same number, there's going to be 4 left and then 3 left. Multiply this out. 5 times 4 is 20, times 3 is 60. There will be 60 different ways.